Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is Find Common Characters. So you will be given a string array words which will be consisting of words, okay, and just like these, and you have to return an array of all the characters that show up in all of the strings within this words array, okay, including the duplicates. Okay, you may return the answer in any order. So for example, if let's say this is the words array that is given to you, okay, so let's say this is our input. So which of the characters are occurring in all of the strings? So this E is occurring in everywhere in the whole strings array, all whole words array, all the words in the words array. Okay, and these two L's are also occurring. Okay, okay, so these three characters are the characters which are occurring in every string, including the duplicate else. So which are those three characters? First is E, then second is L. You can take this blue one, okay, then you can take this yellow one, okay, so this one. So these are the characters that are occurring in every string. Now what we will be doing is we will be returning this array, okay, so this is what we have to do in the problem, okay, and before thinking of an approach, let's have a quick look at the constraints also. So according to the constraints, the length of the words array will be of order 100 and each word can be of maximum size 101, okay, and each word in the given words array will be consisting of only lowercase English letters, okay, so in total there are 26 from small a to small z, okay, so let's try to think of an approach with the help of which we can return the common words. So what we can do is, first of all, if we need to store the frequencies of uh, minimum frequencies of each word, okay, in the whole array. So for example, uh, if we talk about the minimum frequency of a in this particular word roller, okay, or the frequency of a in word roller, so ROLLER. So what is the frequency of a here? A's frequency is 0 here, okay, although A's frequency was 1 here and here also it was 1, but here in this roller word it is 0. So what is the minimum of these occurrences of A, or these frequencies of A? It is 0, okay, so A's frequency is 0. Now similarly we will do for every word, every 26 words from A to Z, and we will try to find out the minimum frequencies across the entire array. So here the frequency of L was 2, here also L's frequency was 2, and here also L's frequency was 2. So what is the minimum of these three? It is nothing but L's frequency, minimum frequency will be 2. So from A to Z, for each of these characters you will be checking their minimum frequencies, okay, across the entire array. Minimum frequency across the entire array. Pardon me if some spelling is incorrect. I hope it does not affect your understanding of the approach. Okay, and so this is the approach. And then once we are having the minimum frequency, then it becomes quite easy for us. So we will just loop from small a to small z and check what were their minimum frequencies. Okay, and if let's say the minimum frequency of L was 2, so we will add, let's say this is the result, list that we will be returning. So we will add that L that number of times. So L's minimum frequency was 2, so we will add L 2 times to the result. E's minimum frequency was 1, so we will add it 1 time only. And rest of all the characters were having minimum frequency of 0, so we will not add them at all. Okay, so this is the approach. Now let's have a quick look at the implementation. Things will be more clear in the implementation, how we are implementing this approach. Okay, so for that I will be taking the implementation code to the board so that I can explain it. Okay, so this is the implementation code. Now let's remove this toolbar for a moment. Yeah, this is the implementation. So first of all, we will be initializing a integer array of 26 size. Why we are only requiring 26 size? From A to Z there are 26 characters. Okay, and if for each character you take its relative difference with small a, then it turns out to be numbers from 0 to 25. Okay, so we are not taking the exact xi values. Instead of that, we are taking relative difference with respect to a, small a. Okay, so from 0 to 25 indices, the 0th index will represent the frequency of a, and 25th index will represent the frequency of z. So that's why this much space is sufficient, and this integer array will help us. The integers represent the relative difference of the character with respect to small a. Okay, so this is how these are the indices. Okay, indices in this array, and this one is also same. So what this frequency current will do, first of all, for the minimum frequency we will fill it with the maximum integer value, which cannot be reached for sure for any character, since the number of characters in the words itself is given to be order of 100. Okay, in each word. So after initializing it, we will traverse over the words array once, and while doing so, what we will be doing is, in each of the iteration, or while we visit each of the words, we will first of all set all the frequencies of the current frequency array to 0. Okay, then we will be checking what are the frequencies of each character in the current word. Okay, so this is the current word that are we visiting. This is the current word, and for each character one by one in the current word, we will be adding its frequency to the frequency current. Okay, so now once we are having the frequencies of words of characters in the current word, then we will update our frequency minimum, okay, of each character, and this whole thing will continue till every word is visited, and its frequency of characters are taken in account for to find the minimum frequency of each character. Okay, so this step is being taken care of. Okay, finding the minimum frequencies, this one. Now proceeding further, we are just left with a frequency minimum array, which is having the minimum frequencies of each character, which are common in every word in the given words array. Okay, so now we are only left with to form our result list that we will be returning. For that, we have to just simply traverse over the given frequency minimum array, which is having indices from 0 to 26. Okay, now let's say for a particular index you are having a non-zero value in this frequency minimum array. It means that the character represented by that index is having more than 0 frequency. In that case, you will add frequency number of copies to the results array. For example, if let's say the frequency of L was 2, then you will be adding 2 copies of L to the results array, just like we did in this particular example. Okay, this was E, by the way. So we added 2 copies of L. Okay, and now coming back. So once we are done with this operation, we will be having our results list, and then we will be returning it simply. Okay, so this is the whole implementation and approach. And if we talk about the complexities, let's examine what will be the time complexity. So this whole outer loop will run for n number of times. If let's say the size of words is n, okay, so n number of times, then this inner loop will run for, again you can say, let's say size of each word is m, okay, m number of times, and it is pretty much constant, although if you want to take it into account, then it can be something like n into m plus 2 into 26. So one for this filling this current frequency array with zeros, and another for traversing this one. Okay, so it is approximately, you can say, order of n into m. Okay, where n is the size of the words array and m is the size of the order of size of the words in the words array. Okay, so both of them were having a maximum value of 100. So 10 raised to power 4 number of order of operations will be required in total, and this will be the time complexity. Okay, so it is also order of 26, so it is pretty much negligible in comparison to this n into m. And if we talk about this loop also, then it will still be running into, you can say, 26 into 100 number of times, okay, at max, because each word was having a maximum length of 100, so at most 100 copies of a particular word can be added. Okay, it will be still less than this, but this whole operation is still less than n into m. Okay, so you can say that time complexity is n into m. And as far as the space complexity is concerned, uh, let me change the color. If you are not taking into account these 26 size arrays and this results array, then it is order of 1 space complexity. But if you are taking these into account, then it will be order of 2 into 26 plus whatever will be the size of this results array. It is quite variable, so we cannot account for that. So if we are talking about the auxiliary space, I think this should be only considered for auxiliary space. So although it's constant, so you can say constant space complexity. Okay, And if you think that this operation will add to some time complexity, it will not be adding, because this is just a constant operation. We are just adding a single character to an empty string, so it will not result into something more than a constant time complexity. Okay, so these will be the complexities. This is the approach. If you are still having any doubts or any queries in general, then you may ask them in the comment section. I hope this solution walkthrough added some value to your DSA journey of owning your DSA skills. Till then, I will see you in the next video, and till then, keep practicing and keep solving problems. Thank you for watching.